Hi, this is Colin Rennie here again, and welcome to another Rhino video. This time I'm going to be doing a series of videos about transforms, the transform tools that you can use within Rhino. The tools I'm going to be using largely, apart from a few simple solids, are largely held under the transform tab here. And you can also get them through the transform drop down menu as well. There's a number of them there, and you can type them into, so for instance shear, you can type them into the command bar if you can remember what it is. The objects I'm going to be making today are similar to this. I'll make something a little bit like this kind of propeller-y type thing, or this turbine type thing. Now for those aeronautical engineers out there, or jet engineers, I am not anything to do with that kind of area. This is purely a kind of sculptural interpretation of these. So these are not designed to be in any way accurate or in any way sort of simulate flow patterns or anything like that. They're just kind of approximations of the kind of thing that you might see. But it's a way of teaching a simple process, which is the transform tool, and a couple of interesting ways of doing it, and there's a little bit of it in here about how to model using the origin points, and the convention of modeling on the center axis. So I'll go right ahead and just hide this stuff for now. Hide here, and I'll start from scratch. So the first thing I'm going to do is start with a basic central boss. So I'm going to start with a tube. If you were to 3D print this object, you might want to put it onto something. You might want to have it onto a shank, a drive shank or something like that, and you need a central tube to it. So I'm not going to be measuring with any precision here. I'm just going to be doing this by eye. So I'm going to start with a boss in the center. I'm going to make this boss around about here. The tube has two excuse me, has two diameters, one for the inside diameter, one for the outside diameter, and it also has the height position. So I'm going to make the height kind of where I need it, about there, something around that. And the second thing I'm going to need is a truncated cone, something like this. There are various other shapes you could use. You could use a tube and shape it. Oops, that wasn't truncated cone. I need truncated cone, which is this. And I'm going to move into the perspective, outer perspective, and I'm going to make this from the 0. So this, I'm going to make it about that high. So it's a bit smaller than the object. I'll just do that again. I'm just going to take my smart track off. Yeah. So I'll make it about there. Then the outside of my cone, I'm going to make it going in this direction, and then the end of my cone I'm going to make about something like that. So I've got a truncated cone here. Don't worry about it being off center at the moment. I'll work with this in a minute. The second thing I'm going to do is do a non-uniform scale. Actually, I'll do a scale in one dimension. I'm going to scale this from the 0 point. I'm going to make it thinner. So I'm going to make it like an aerofoil kind of thickness, something like that. And the last thing I'm going to do to this particular part is I'm going to twist it, because propellers have a higher pitch angle towards the center and a shallower pitch angle towards the edge, and that's because the velocity of the air at the center in rotation is slower than the velocity at the tips of the propeller blades, which are obviously moving faster. So the relative angle needs to be proportional to that. So I'm not going to actually do a proportional twist. I'm going to do a uniform twist here, which I know is not accurate, but it will give the appearance of the kind of thing we want. So I'll do a twist first, and a twist you'll find under transform, and this is twist here. So a twist requires an axis. Now because this is an ovoid, it should still have a send. So I've got send here, so it should still have a send. There it is. And I'm going to choose send on the other side as well. So I'm not twisting it in anything other than the complete center of the axis, and then I'm going to, let's go this way. I'm going to twist this from tip to back. Okay, so I've twisted that object there. That's looking okay. And then what I'm going to do is I'm going to join this up and put it more or less centrally within the boss. There, something like that. Now I'm also going to be filleting this, so I just need to look and make sure that I've got enough room around the outside to fillet it with a decent size of fillet. And that seems okay. I'll probably have a 2mm, maybe a 1mm fillet around there would do it. I'm actually probably only a 1/2 mm fillet, but we'll have a look at that when we come and fillet it. So now I've twisted it, what I'm going to do is I'm going to array this around the center. So I'm going to use a polar array, which is found under the array tools. It's also here in transform, it's polar array. So I'm going to choose the object, and then I'm going to press enter when done. Center of polar array is 0, enter. And the number of items is 5 propellers, and then enter, enter, enter will give me the basics of the propeller like that. But at the moment it's looking not very much like a propeller because I need to twist it. But before I twist it, I'm also going to boolean the whole thing together. So I'm going to select everything and just boolean union everything together. Now when I did that, if you look, I moved the I'll undo that there. I look at it in X-ray, so you can see I'd moved the ends of the propeller blades so that they were sitting inside the mass of the tube that I've made. If they were protruding through the other side, you'd end up with some funny results. Because when I run the Boolean union, you'll see I want to select everything. I want to have only the internal edge there. So I've created one edge, not two. I don't want any more sort of guffy geometry in there. So that's that. So now I've done that, I can go ahead and fillet that. Change back to shaded view. I prefer that. I need to fillet these edges here. So I'm going to do fillet edge. There's fillet edge. It came up there, I missed it. And the radius is set at the moment to 5. I'm going to set the radius to 1 here just to try. It's probably going to be too big, but we'll try it anyway. And I don't want, I'll hold my control key down here. I don't want this edge, I don't want this edge, I don't want this edge, and I don't want this edge. It's easier, and I also don't want that edge. I just want those edges there. Could have manually selected them probably with a similar number of clicks. But I'll think about it for a while, and it's a little bit close. It's actually overlapping, so that's not great geometry. So I'm going to have to do that with a smaller radius. So that was 1. I'll do it at 0.7, and again do the same thing. Quite often with fillets, you need to try a few different fillet size balls before you get the right one. I could also make that boss higher. No, that's fine. That's going to be okay. I mean, if I later on wanted to fillet this, I'd be a bit restricted, but I could always extend this edge. It's still a cylinder. I could extend this edge if I wanted a bit more room there. But that should be fine. It should add a little bit of strength to this union here to make sure that it doesn't weaken. And the next thing I'm going to do is to twist the whole thing. So it's all one object now. So I'm going to twist it again here, and the start of the twist axis I'm going to use the 0 point. I'm going to go straight up here to here. I'm going to choose a point on the outside, and then I'm going to twist all the objects. I'll just turn on, just disable my snaps at the moment. So you can twist it any number of times if you want to, so I can make very broad propellers like this, or slightly narrow ones. So I'll go with, yeah, maybe something like that. Seems fairly decent. A little shallow on the tips there, but that's okay. Now the ends of these blades are not particularly shaped in any nice way. I might want to profile these a little bit, so I might want the leading edge, which is this edge here, to be blunter, and the tailing edge tailing off. So this is the leading edge. I'll just check that, make sure there's a point. I'll put a point up here and highlight it. Point rather, somewhere there, and highlight that point. So yeah, that's the leading edge, the front edge. Just delete those 2 points. So I'm going to draw a curve. So I'm going to make sure my curve intersects the line. So I'll just skirt it in like this, and then here something like that. So I could edit that, point edit that, just to sort of pull it around a little bit if I wanted to, just to change the shape of my blades. If I want to, I could pull that in if I want to, but we'll just go with that for now. And just because sometimes when that one's okay, I haven't moved it around at all, but if you accidentally had pulled any of the control points up, so you had accidentally, if I take this control point, I'll just demonstrate this, and you'd accidentally pulled it off the construction plane like this, and so your curve wasn't flat anymore. You might not notice that, but it won't particularly work very well if you did it. It's always a good idea to transform in this viewpoint, my top viewpoint, transform, project to C-plane, delete input yes, and that will flatten the curve. You can see there's no height to that curve at all. The next thing I want to do is extrude that curve vertically so it intersects all the way through. So I want a solid, no it's not, it's a surface. Extrude curve straight. So I want to make sure that intersects all the way through, something like that. So I have full intersection here, but I'm not going to trim this and then move it around. What I'm going to do is the same array, because that is in the right position. I need to do the same polar array. Center of polar array is 0, enter, 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 because the numbers is going to be the same. It's 5, it's sticky, so it will stay as 5. And press enter again. So now I have all these trimmings. I'm going to select them all with my shift key down. And there they are. And I'm going to trim away, split, I need trim, the outside edges. There we go. And escape that. And then I'm going to do the reverses, kind of like a manual boolean. Probably could do a boolean on it, but I prefer to do it manually just to make sure I'm full control over it. So I'm going to trim away the outside edges of my curves, of my curved walls, if you like. Okay. So now I have, if you look closely at the edge, you'll see there is an edge there, which is left over, which is what we want. I'll just join everything up. Oops. Join everything up. Hitting the right button, there we go. Join everything up, so we should have one closed poly surface. So I'll just check that in the properties, details. I have closed poly surface with 19 surfaces, so that's what we need. And then I can mesh that out and print it. So there's basically a 5-bladed propeller, fairly quickly done in Rhino using twist, polar array, and scaling in 1 dimension. And that's it. So I hope you enjoyed that video, and shows you a little bit about how to do these things, do some of these shapes using some of the simple tools in Transform. It's a very powerful tool. By the way, if you think, oh no, I've managed to do my propeller and I've done it the wrong way, my remote is turning the other way, and I need the propeller to turn in the opposite direction, well, there's another transform that quickly solves that problem for you. You could just mirror the whole thing. Select object to mirror, press enter when done, start a mirror plane, say something over here, end a mirror plane, something over here. So now we have one of these that is a clockwise and one of these which is an anti-clockwise propeller. Very easily done. If you make a mistake, a stupid mistake like turning a propeller left hand rather than right hand. So there you go, there's a number of tools for you. Hope you enjoyed that video, and see you for the next one. Thank you.